السلام عليكم ورحمة الله وبركاته. Hello, grade 11. Here with you, Miss شيماء الغمري, chemistry teacher. إن شاء الله today we are going to revise the chemistry curriculum for our year. Our chemistry curriculum for this term is made up of two chapters, Chapter 3 and Chapter 4. Chapter 3 has 4 lessons, and Chapter 4 has only 2 lessons. Let's start with the first lesson in Chapter 3. The concept of chemical reaction. Why do the elements tend to share in the chemical reaction? The elements tend to share in the chemical reaction to reach the stability and to achieve the electronic configuration of the nearest noble gas, so they will be stable, such as the electronic configuration of helium, which is 1s2, neon 2s2, 2p6, argon 3s2, 3p6. So as you can see, the outermost energy level of each noble gas has 8 electrons. So the elements tend to share in any chemical reaction to reach the stability and to achieve the electronic configuration of the nearest noble. So what is meant by the chemical reaction? The chemical reaction concept means what? The breaking down in reactants and forming new bonds, the breaking bonds in reactants and forming new bonds in product. This breaking down the bonds in reactant need energy, and forming new bonds release energy. Lewis electron dot symbol. Lewis dot electron symbol, or Lewis and Lewis scientist put his structure to represent the element. Lewis said that we are going to use the valence electrons to draw the elements or to express the different atoms of the elements. Why did he choose the valence electrons? Because from the valence electrons, you can detect the type of element. From the valence electron, you can say if the element or if the atom is active or not active, if it is metal or non-metal, and so on. So valence electrons, the electrons are involved in what? In the chemical reaction. Example, if we said that we are going to draw Lewis dot sample for sodium. Sodium 11, so it has only 1 electron in the outermost energy level. So its Lewis dot structure will be represented by only 1 dot on what? On the sample of sodium. So this is Lewis electron dot sample. Another example, nitrogen 7. Nitrogen 7 has 5 electrons in the outermost energy level. So it has 5 valence electrons. We are going to put the first electron on the upper part and then move counterclockwise. So 1, 2, 3, 4, 5. This is the Lewis dot sample for nitrogen. Scientists Lewis differentiate between lone pair and bond pair electrons. So we are going to talk about what the Lewis structure in the compound. So or in the molecule of a compound. So if we have an example such as NH3, as we said that nitrogen is surrounded by 5 electrons. So 1, 2, 3, 4, 5. And here it is attached with 3 hydrogen. So here we have hydrogen which share with an electron from nitrogen, and another hydrogen share its electron with the other electron of nitrogen, and another hydrogen which also share electron with the other electron from nitrogen. Now we have 3 bond pairs. This is a pair of electrons which made a bond. This is another pair which made another bond, and this is another pair which made a bond. So we have 3 bond pairs in what? In nitrogen, in NH3. And how many lone pairs of electrons do we have? We have only 1 lone pair of electrons. So we have 1 lone pair of electrons. So we can say that bond pair are the pairs which are involved in making bonds. Lone pairs, they are the free electrons which do not share in making bonds. What are the types of bonds? We have 2 types of bonds. We have chemical bonds and we have physical bonds. In the chemical bonds, we have 3 types. We have ionic bond, covalent bond, and coordinate bond. In the physical bond, we have 2 types, which are hydrogen bond and metallic bond. In covalent bond, we have 3 types, which are pure covalent bond, non-polar covalent bond, and polar covalent bond. Let's start with the ionic bond. The ionic bond takes place between what? Metal plus non-metal. So metal usually lose electrons and form positive ion. Non-metal usually gain electron and form negative ion. So we have positive ion and negative ion. Then there is electrostatic attraction between the positive ion and the negative ion, forming the ionic bond. Which of the following represent the bond in sodium bromide? So as we said that the bond in sodium bromide, sodium is a metal which has 1 electron in the outermost energy level. Okay. And bromide is a non-metal which has 7 electrons surrounding it in the outermost energy level. So if we apply the Lewis diagram, so it's 1, 2, 3, 4, 5, 6, 7. So bromide need only 1 electron. What will happen? Sodium will lose this electron and bromide gain this electron, and forming sodium positive ion and bromide negative ion. Then there is electrostatic attraction between the positive ion and the negative ion. So the correct choice is B. The ionic bonding and electronegativity. By increasing the difference in electronegativity between the metal and the non-metal that we have, so some characteristics or some physical characteristics will increase or decrease according to what the difference in electronegativity. If the difference in electronegativity increases, that means the melting point and boiling point of the ionic compound also will increase. If the difference between the metal and the non-metal, if the difference in electronegativity between metal and the non-metal decreases, that means the melting point and the boiling point also will decrease. If the difference in electronegativity decreases than 1.7, so we will not have ionic compound. So the ionic compound start from the difference between metal and non-metal, the difference between them should be greater than 1.7. So as we can see here in sodium chloride and magnesium chloride and aluminum chloride. Sodium chloride, the difference between an electronegativity between chlorine and sodium is 2.1. In magnesium, the difference is 1.8. In aluminum, the difference is 1.5. So as you can see, the melting point of sodium chloride is really high, or the highest one, because it has the greatest difference. The difference in magnesium less, the difference in aluminum chloride is very low. And also the boiling point and the electric conductivity. By increasing the difference in electronegativity, the electric conductivity increases. So the difference in electronegativity is high, so we have very good conductor, and magnesium chloride is good conductor, but aluminum chloride doesn't conduct electricity because the difference in electronegativity is less than 1.7. So the ionic bond is a chemical bond which is formed between metal and non-metal. The difference in electronegativity between them should be more than 1.7. The covalent bond okay. For covalent bond, we have three types of covalent bonds. We have pure covalent bond, we have non-polar covalent bond, and we have a strong polar covalent bond. Okay, the pure covalent bond means the difference in electronegativity between them equal 0. The difference in electronegativity equal 0. In a non-polar covalent bond, the difference in electronegativity is from 0 to 0.4. This is non-polar covalent bond, the difference in electronegativity between the two atoms. In polar covalent bond, so in pure covalent bond, the difference in electronegativity equals 0. In non-polar covalent bond, the difference in electronegativity between 0 to 0.4, greater than 0, L 0.4. In polar covalent bond, the difference in electronegativity greater than 0.4 till 1.7. If the difference in electronegativity greater than 1.7, so we have greater than 1.7, so we have ionic bond. Let's check our understanding. Which of the following represent the polarity of the bond? Okay, the expression for the polar covalent bond is expressed by an arrow directed from the weak electronegative atom to the strong electronegative atom, because the strong electronegative atom pull electrons toward itself. So here we have weak electronegative atom to strong electronegative. The bond between carbon and hydrogen, its electronegativity, the difference in electronegativity between carbon and hydrogen is 0.4. So it's not, it's non-polar covalent bond. The bond between chlorine and carbon is a polar covalent bond. But chlorine is stronger in electronegativity or higher in electronegativity than carbon. So it's supposed for chlorine to withdraw the electron toward itself. So the direction of the arrow should be directed toward chlorine. So C is the correct choice because fluorine has higher electronegativity, so it attracts electrons toward itself. Water molecule is a polar molecule. Why it's polar molecule? Because the difference in electronegativity between oxygen and hydrogen. Also, ammonia molecule is a polar molecule because the difference in electronegativity between nitrogen and hydrogen is high. But the polarity of water is greater than the polarity of ammonia because the difference in electronegativity between oxygen and hydrogen is greater than the difference in electronegativity between nitrogen and hydrogen. As we can see here, the difference in electronegativity in water is 1.4. The difference in electronegativity in ammonia is 0.9. So finally, if we have the difference in electronegativity 0, so we are talking about pure covalent bond. Between 0 to 0.4, we are talking about nonpolar covalent bond. Greater than 0.4 till 1.7, so we have polar covalent bond, and the polarity increases by increasing the difference. Greater than 1.7, we have ionic bond. Lesson 2 is talking about theories explaining the covalent bond. The first one is the electron theory of valency or octet rule. Octet rule was established by Lewis and Kossel. They said that the element tended to have 8 electrons, or surrounded by 8 electrons except hydrogen and beryllium. In the outermost energy level and have the redraw the structure of the opposite hydrazine molecule showing Lewis electron dot representation. So I'm going to put the electrons of nitrogen. Nitrogen is surrounded by 5 electrons. So it's 1, 2, 3, 4, and here 5. For another nitrogen, it's 1, 2, 3, 4, and here 5. For hydrogen shared by 1 electron. So we have 3 here is 1 pair of electron, 2 pair of electron, 3 bond pair, 4, and 5. So we have 5 bond pairs. And how many lone pairs of electrons do we have? On the first nitrogen, we have 1. On the second nitrogen, we have 1. So we have 2 lone pairs of electrons. The drawbacks of octet rule. Octet rule couldn't explain some molecules, such as the molecule of PCl5. Here we can find that phosphorus is surrounded by 10 electrons, and according to octet rule, it's supposed to have only 8 electrons. Also, it couldn't explain the molecule of BF3. Another drawback for octet rule, it couldn't explain the stereostructure of the molecule and the angle between the bonds. Which of the following pair doesn't obey the octet rule? Doesn't obey the octet rule. Sulfur here is surrounded by 6 fluorine, so we have 6 bonds, so we have 12 electrons surrounding sulfur. Nitrogen in F3, this obey octet rule because nitrogen form 3 bonds with fluorine with 6 electrons, and nitrogen has 1 lone pair of electron, so it is obeying octet rule, but the pair doesn't obey the octet rule. One of it doesn't obey, the other one obey the octet rule. Here OF2. OF2 oxygen made 2 bonds with fluorine. So we have 4 electrons. Oxygen had 2 pairs of lone electron, so another 4. So it has 8 surrounding the oxygen, so it obeys octet rule. But BF5, we have 5 fluorine, so 5 bonds, so 10 electrons, so doesn't obey the octet rule. 1 obey, 1 not obey. SF6, the same as the previous one, BF5 has 10, here's 12, so both of them doesn't obey the octet rule. Here OF2 obey the octet rule, NF3 obey the octet rule. So if you find the number of electrons greater than 8, it's not obeying the octet rule. The number of electrons less than 8, you should check if the atom had 3 lone pairs of electron or doesn't have 3 lone pair of electron. Valence shell electron pair or Whisper theory. Valence shell electron pair repulsion. Whisper theory. Whisper theory, a theory explain that the electron pairs, سواء if they are free bonded or bonded, free and bonded, lone pairs and bond pairs, are distributed in space around the central molecule where the repulsion between them is minimal. In Whisper theory, we will need this abbreviation or this formula to express any molecule. A represent the central atom, X represent the atoms bonded with the central atom, and N represent the number of atoms, and E represent the lone pairs of electrons, M represent the number of lone pairs of electrons. I'm going to use the abbreviation, and then we will say the stereostructure and the arrangement and an example and the angle between the bonds. The abbreviation, if we have the abbreviation AX2, so the arrangement of the bonds will be linear arrangement. Stereostructure also will be linear. If there is no free electrons or lone pairs of electrons, the arrangement will be usually equal to or the same as the stereostructure. Example, we can take an example such as carbon dioxide. Carbon dioxide, its abbreviation is AX2. Carbon doesn't carry any lone pair of electron. The angle between the bonds is 180. Abbreviation, another abbreviation, AX3. AX3, its arrangement is planar triangle. Its stereostructure also planar triangle, the same, because it's not having lone pair of electron. It's A, the central atom, surrounded by X from the all directions. Here, example, PCl3. PCl3 boron is an atom which is satisfied by having only 6 electrons surrounding it. The angle between them is 120. AX4. Tetrahedral arrangement, tetrahedral. The stereostructure, tetrahedron. The most famous example is CH4. The angle between them and the stereostructure is 109. Another example, AX2, AX2, E2. Now the lone pairs of electrons start to appear. I'm going to say what? The central atom is surrounded by how many things? It is surrounded by 2 atoms and 2 lone pairs of electrons. So we have 4 things surrounding the central atom. So its arrangement is tetrahedral. But the stereo structure will be different. Why? Because we have 3 lone pairs of electrons. So the stereo structure will be angular. Example, H2O. And the angle will be 105. Another example, AX3E. AX3E. Here, AX3E represents one central atom surrounded also by 4 things. So here it's also tetrahedral arrangement. But the stereo structure will be different. We have 3 main atoms, so we have 3 base pyramid. 3 base pyramid. The example is NH3. The angle between them about 107. These are all the examples and abbreviations for whisper theory. Number 2, the valence bond theory. Valence bond theory explains that the covalent molecule has 2 or more atoms enclosed to each other of the same orbital, which is a half-filled valence orbital, and the orbital should contain only 1 electron, have overlapped with each other to form a covalent bond in the molecule, and the rest atom of orbital which didn't take part in the formation of bonds remain as they are. The valence bond theory, to explain the valence bond theory, we depend on 2 main concepts. The overlapped orbital, as we said in the definition, an orbital half-filled, another orbital half-filled, overlap on each other to form the covalent bond. The rest orbitals, which are filled with electrons or don't share in forming the bond, remain as they are. Then we have overlap concept and hybridized concept. The first overlapped concept, as we can see, forming hydrogen fluoride. Hydrogen has s orbital, which contain only 1 electron, and fluorine, as you can see from the distribution of electrons, fluorine has only 1 half-filled orbital, which is 2pz. So there is overlapping between what? Between the s orbital of hydrogen and this 2pz to form what? The covalent bond between hydrogen and fluorine. And it appears by this way, but the rest orbitals remain without any change. The bond in HCl molecule arises as a result of overlapping of 1 s orbital of hydrogen with 1 atomic orbital of chlorine. Which of the following represent this atomic orbital of chlorine? As we know that chlorine is chlorine 17. So the electronic configuration of chlorine will be 1s2, 2s2, 2p6, 3s2, 3p5. So the orbital which will be half-filled is found in what? In p sublevel. So p sublevel has 3 orbitals, which are px and py and pz. And p sublevel contain 5 electrons. So electrons are distributed in 1, 2, 3, 4, 5. So the orbital which is half-filled, which is going to overlap with 1s orbital of hydrogen, is what? 3pz. 3pz. The failure of overlap orbital to explain the methane molecule. As we know that methane molecule CH4. So here carbon is bonded with 4 hydrogen. But if we write the electronic configuration of carbon, we will find carbon has only 2 free electrons or 2 half-filled orbitals. So how did carbon could form 4 bonds with hydrogen? So the first failure for this orbital that it couldn't explain how carbon make 4 bonds and how the angle between them is 109 and not greater than that. So they started to think about the excitation or the transfer of 1 electron from 2s2 to 2p2. So now we have 4 half orbitals, but they are not equal in energy because the orbital of 2s has different the orbital in 2s has different energy than orbitals of p sublevel. So they started to think about what? The hybridized orbital concept. The hybridized orbital concept, there is hybridization will take place between what? Between 2s orbital and 2s sublevel and 2p sublevel. This hybridization resulted for what? For 4 new orbitals with the same energy and the same shape. So after hybridization take place, we will get the same, we will get orbitals with the same energy. What is meant by hybridization? The process of overlapping or combination 2 or more different orbitals of the same atom to produce a number of new similar orbitals called hybridized orbital or hybrid. The conditions of hybridization process to take place, it should take place inside the same atom. It also occurs between orbitals of close energy. So it takes place between 2s and 2p, but it doesn't take place between 1s and 2p, for example. The number of hybrid orbital equals the number of pure orbital undergo hybridization. So at the end of hybridization, we will have 4 orbitals, 1 orbital from S and 3 orbitals from P. So we will get 4 hybrid orbitals. Which of the following sublevels, their orbitals can be hybridized? We said that they should be in the same atom and they should be close to each other in the energy. For sure, we don't have P sublevel in the first energy level, so A is not correct. 2s and 3p, or 3s and 3p, or 3p and 4d. For sure, we are going to choose the same energy level, the sublevels of the same energy level, because they are close enough to each other in energy. The hybridization type, we have sp hybridization type or sp3 hybridization type, sp3 hybridization, the hybridized orbital, one orbital from S, one from S, plus 3 orbitals from P. So the total orbitals that we have finally 4 hybrid orbitals. 4 hybrid orbitals, all of them have the same name, which is what? sp3. So sp3 hybridization type means 1 orbital from S and 3 orbitals from P. And the hybridized orbitals for sp3. The shape of them take this shape, which is a tetrahedral shape, and the angle between them is 109. sp2 hybridization. The hybridized orbital, 1 orbital of S and 2 orbitals of P, resulting 3 orbitals, all of them have the same name, which is what? sp2. It takes the shape of planar triangle, and the angle between them is 120. Finally, sp hybridization. 1 orbital of S and 1 orbital of P to get 2 hybridized orbitals. All of them have the same name, which is sp hybridized orbital. The angle, it takes the shape of linear, which has angle 180. Explanation of the structure of methane. After we explained the excitation and overlapping and hybridization, now we are able to explain the structure of methane. As we said that carbon has what? 4. Carbon is binded with 4 hydrogen. So carbon 6, it has 1s2, okay, then 2s, 1s orbital has 2 electrons in it, and here 2s2, so it also has 2 electrons, 2p, 2p2, okay. The first step is the excitation of 1 electron to move to the upper part. So we will have this structure, which is 1s2, 2s after excitation, it has only 1 electron, and 2p after excitation has 3 electrons, 2s and 2p. After that, hybridization process take place. So we will have 1s2, which remain without any change. And we have 4 orbitals. All of them have 1 electron. All of them have the same name, which is sp3, 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 sp3. All of them are ready to overlap with what? With 1s, with 4 s orbitals from 4 hydrogen atom to form methane molecule with angles or with tetrahedral stereostructure, and the angle between them is 109. The opposite figure in the structural formula of propane, what is the type of hybridization which occurs in carbon atom in this compound? I'm going to look at carbon. Carbon is surrounded by 4 bonds. So it means 4 hybridized orbital. So 4 hybridized orbitals come from the hybridization of what? Of 1 from S and 3 from P. So the type of hybridization is sp3. The molecular orbital theory. Molecular orbital theory deal with molecules as big atoms. They deal with the molecule as a unit or a big atom with multi-nuclei in which all atomic orbitals of the combined atoms are mixed or hybridized, forming the molecular orbitals. What are the molecular orbitals? We have sigma bond, pi bond, and delta. So we have sigma bond, pi bond. Sigma bonds take place between what? Between 2 p orbitals, but what? Head by head. They overlap head by head to form what? Sigma bond. Or with S and P, also head by head. So it also forms sigma bond. The sigma bond take place between what? Between S orbital and P orbital, head by head. But pi bond take place between 2 p orbitals side by side. Usually you can find the pi bond in what? In double covalent bond, in triple covalent bond. If you have a single covalent bond, it's sigma bond. If we have double covalent bond, one of them is sigma and the other one is pi. If you have triple covalent bond, one of them is sigma and the 2 other bonds are pi bonds. The explanation of structure of ethylene molecule. Ethylene molecule C2H4. C2H4 means we have 2 carbon atoms binded with 4 hydrogen. So I'm going to distribute hydrogen. Here 1 hydrogen, here 1 hydrogen, here 1 hydrogen, and here 1 hydrogen. So carbon need to complete what? 4 bonds. So it forms double bond between carbon-carbon atoms. The type of hybridization, here we have 3 sigma bonds. Only 3 sigma bonds and 1 pi bond. So the type of hybridization in ethylene molecule is what? Is sp2. sp2. Why? Because as we said, if we have double bond, one of them is sigma bond and the other one is pi bond. So pi bond between p orbital and p orbital, not hybridized orbital. So the type of hybridization here is sp2. One carbon atom, which electronic structure of carbon is 1s2, 2s, which contain 2 electrons. After excitation, it has only 1, and 2p, which has 3 electrons after excitation. So this is px and py and pz. Px, py, and 2s are going to hybridize with each other without what? Without pz. And pz will not share in hybridization. After hybridization, the shape of the structure of carbon, this is 1s2. This is 2s with 2p hybridized orbital of 3 orbitals hybridized, and pz remain without any hybridization. So this pz is going to overlap with pz of the other carbon atom, side by side to form pi bond. Here we have 3 sp2 hybridized orbital. Each of them will form a sigma bond with 2 hydrogen atoms and 1 sigma bond between carbon-carbon atom. Acetylene, C2H2. So we have carbon and carbon, 1 hydrogen and 1 hydrogen. So carbon need to complete the 4 bonds. So there is triple covalent bond between carbon-carbon atoms. As we said, the triple covalent bond means only 1 sigma bond and 2 pi bonds. Here sigma bond, here sigma bond. So the carbon atom is surrounded by only 2 sigma bonds. So the hybridization is what? sp hybridization. 1 from S and 1 from P. How to determine the hybridization in a compound? If we have any compound, we want to know the hybridization. The hybridization is represented by sigma bonds and lone pair of electrons if they are found. Sigma bonds and lone pair of electrons if they are found. So what is the type of hybridization in BeF2? BeF2, beryllium is exception from octet rule. So beryllium is very happy with having 4 electrons surrounding it. It's stable and happy. So here the angle is 180, and beryllium form a bond with fluorine and another bond with, as it is single bond, so we have 2 sigma bonds surrounding beryllium. So the hybridization is what? sp hybridization. Third, the coordinate bond. What is meant by coordinate bond? Coordinate bond, one atom which has 3 or lone pairs of electrons share or give or donate these 2 electrons to another ion or atom which need these 2 electrons. The coordinate bond is represented by an arrow from the donor atom to acceptor atom. Let's explain the coordinate bond in ammonia molecule. In ammonia molecule, as you can see in the structure of nitrogen atom has 1 s2, 2 s2, and 2 p3. So ammonia will form sigma bonds with 3 hydrogen atoms, and it has 3 lone pairs of electrons. If there is hydrogen ion is coming beside ammonia, hydrogen ion, so without any electron, the ammonia molecule will donate this hydrogen ion with lone pair of electrons to form NH4 or ammonium ion, NH4 positive. So nitrogen here is what? The donor atom, and the hydrogen ion is the acceptor atom. The arrow extended from nitrogen toward hydrogen. There are different types of bonds in molecule of ammonium chloride. What are the types of bonds in ammonium chloride? Between nitrogen and hydrogen, there is what? There is covalent bonds. It's polar covalent bonds. Between nitrogen and hydrogen ion, there is what? Coordinate bond. So this is the second type of bond. Between NH4 positive and Cl negative, there is ionic bond. So there are different types of bonds in molecule of ammonium chloride. Which of these types exist in this molecule with the highest number? Which one is found with the highest number? We can see that it has 3 covalent bonds with hydrogen. 3 polar covalent bond with hydrogen. So the polar covalent bond is found with highest number. The following abbreviation represent molecule that can form coordinate bond, except the molecule which make the coordinate bond should have lone pair of electron. So the one which doesn't have lone pair of electron is B, so it's not able to form a coordinate bond. Finally, the physical bonds. The physical bonds are hydrogen bonds and metallic bonds. Usually, hydrogen bonds take place between one molecule which contains hydrogen and another one of high electronegativity. Another molecule which contains an atom with high electronegativity. Okay, hydrogen bond between water molecule. Water molecule contain oxygen and hydrogen. So there is a hydrogen bond which is formed between oxygen of one atom and hydrogen of oxygen of one molecule and the hydrogen of another molecule. Between oxygen of one molecule and the hydrogen of another molecule. All the following can form a hydrogen bond except hydrogen bond usually found with nitrogen, fluorine, and oxygen. Except of these three, the hydrogen bond is not formed. So C is the correct choice. The strength of hydrogen bond. Hydrogen bond is weaker than what covalent bond. Why? Because it is longer than covalent bond. Its length for covalent bond is 1 angstrom, but hydrogen is 3 angstroms. So the bond strength of covalent bond is greater than the bond strength of hydrogen bond because hydrogen bond is longer than the covalent bond. Finally, the metallic bond is a bond between the free valence electrons or free electrons of the outermost energy level of the metals. As we know that all metals have 1 or 2 or 3 electrons in the outermost energy level. These electrons are free surrounding the atoms or the nucleus of the metal. So there is bond attraction between the ions of the metal and the electrons or free electrons surrounding it, which forms a cloud. This metallic bond may be weak if the element or the metal has only 1 electron in the outermost energy level, and it increases, or its strength increases by increasing the number of electrons in the outermost energy level. Finally, we reach to chapter 4, lesson 1. Elements of S block. Elements of S block. As we know, S block is made up of group 1A and group 2A. We are going to focus on group 1A elements, which are lithium, sodium, potassium, rubidium, and cesium, and francium. Francium, which is a radioactive element, or it's not found in nature. As we can see in the graph, that all of them end with the same S sublevel, which contain only 1 electron with different energy levels. Abundance of alkali metal in nature. Sodium is the most abundant alkali metal, and potassium. The sodium is found in rock salt, and potassium is found in seawater, and it's found in carnallite deposit, JCl, MgCl2, 6H2O. Which of the following alkali metal, the mass of the sample of it decrease over time? As we said that francium is a radioactive element, so the one which decay because it has very short lifetime or half-life time. So francium is the one which decreases, or its mass decreases by the time because it's radioactive element. General properties of alkali metal. Number one, the presence of single electron in the outermost energy level. The presence of single electron in the outermost energy level makes the ionization potential energy low, makes the elements, or metals tend to lose these electrons and form positive ion, makes the elements or metals, these metals, to start each period in the periodic table because they have only one electron in the outermost energy level. They also have the largest atomic size. They start each period, so they have the largest size in their periods. Because they have the largest size, also they have the least ionization potential. They are very active metals, and they are affected by light to release their electrons from the outermost energy level, which is known as photoelectric effect. Cesium is used in photoelectric cell. Why? Because cesium has very large size, very low ionization potential. Lithium element is not used in photoelectric cell. Why cesium is used but lithium is not used? Its ionization potential is high compared to the light energy, or its atomic radius is large, its electronegativity is high, its valence shell contains only one electron. For sure, its electronegativity is high. Is it correct? Its electronegativity is high. Or its ionization potential is high compared to the light energy. A is the correct choice, because if the light energy is not enough to make ionization, so it can't be used to in electric cell or photoelectric cell. It has high electronegativity compared to what? To its group. As we know that the electronegativity decreases down the group and increases through the period. The atomic spectra or dry flame test. We use dry flame test to distinguish between different elements, so you should memorize these colors. Lithium in dry flame test has crimson color, sodium has golden yellow, potassium blue violet, and cesium has bluish violet. The effect of atmospheric air, as we said, that these elements are very active. They have very low ionization potential energy, so they react spontaneously with air, and this activity increases down the group. Sodium, as you can see, the piece of sodium has luster in front of you. Lithium can react with nitrogen in air in the presence of heat to form lithium nitride. This lithium nitride, when dissolved in water, form lithium hydroxide and ammonium gas evolves. The reaction of alkali metal with water, they react with water vigorously, and the vigorous action increases down the group due to the increase of reactivity and the decrease of the ionization potential. So as you can see in the picture, lithium react with only bubbles. The sparks start to appear from sodium and increases in potassium. So the reaction between alkali metal and water is a vigorous reaction. All of them react with water, forming basic oxide, and hydrogen gas evolves. Reaction of alkali metal of oxygen, they react with oxygen and give three different oxides: the normal oxide, peroxide, and superoxide. If the element is active, if it is less active, it forms only normal oxide. If it is more active, it forms peroxide and normal oxide. If it is more and more active, it can form superoxide. What is the difference between them? The difference between them is relative to what the oxidation number of oxygen in this oxide. For normal oxide, the oxidation number of oxygen in this oxide is -2. And in peroxide, the oxidation number of oxygen in this peroxide is -1. In superoxide, the oxidation number of oxygen is -1/2. So here in normal oxide is Na2O or Li2O. The oxidation number of oxygen here -2. And in peroxide, such as Na2O2. Here, the oxidation number of oxygen -1. In superoxide, such as KO2, the oxidation number of oxygen here is -1/2. Which of the following show the correct sorting of oxide? KO2. Is it peroxide? KO2, here the oxidation number of oxygen is -1/2, so it's superoxide, it's not peroxide. H2O2, here the oxidation number of oxygen is -1, so it's peroxide. So H2O2 is peroxide. KO2, the oxidation number -1/2, as we said. So we have two choices, B and D. We exclude A and C. In superoxide, we said that the oxidation number should be -1/2, so we are going to choose KO2, which is B. So the correct choice is KO2, or B is the best choice for peroxide and superoxide and dioxide. The peroxide and superoxide act as oxidizing agent. They have more oxygen. So when they react with water, when they react peroxide and superoxide, they give water, peroxide of water. And if it is peroxide, sodium peroxide, for example, react with water, produces sodium hydroxide and hydrogen peroxide. Sodium peroxide, when react with acid, give us the salt, which is NaCl, and the hydrogen peroxide. What about the superoxide? When superoxide react, because it has more and more oxygen, so when it reacts with water, it gives us potassium hydroxide, hydrogen peroxide, and gas, oxygen gas evolves. So potassium superoxide, when react with acid, give us salt and hydrogen peroxide, and oxygen gas evolves. Potassium superoxide react with carbon dioxide gas, giving oxygen. So it is used in submarines and the closed areas to filter the air from carbon dioxide and recharge the air with oxygen. So potassium superoxide will react with carbon dioxide in the presence of copper chloride as a catalyst to give potassium carbonate and free oxygen. What is the similarity between the reaction of potassium superoxide with both water and hydrochloric acid? How it is similar? The product of reaction of potassium superoxide with both water and HCl is forming what? Hydrogen peroxide. Salt and water, a metal hydroxide, colorless substance, acid and hydrogen. The similarity between the action of potassium superoxide with both water and hydrochloric acid. It forms salt and water? No, it forms colorless substances, or it forms metal hydroxide. It forms metal hydroxide in case of reaction with water. It forms salt in case of reaction with acid, so not metal hydroxide. And form colorless substance, yes. So B is the correct choice. The action of alkali metals with hydrogen. When alkali metals react with hydrogen, they form ionic hydrides. These hydrides act as a reducing agent because when they react with water, they give lithium hydroxide and hydrogen gas evolves. Okay, when ionic hydride compound react with water, it yields ionic hydride react with water. It yields what? Hydroxide, an acidic solution? No. A basic solution, positive hydride ion, negative metal ion. For sure, it's basic solution. The reaction of alkali metal with acid, alkali metal can replace hydrogen in acids with a vigorous reaction. So if we react sodium directly with HCl, it forms NaCl plus H2O, H2 gas with a vigorous reaction. So it's not a suitable step or idea to form salts by direct reaction with acids. Alkali metal react vigorously with halide, vigorously. With what? With halide. So if we react sodium with chlorine, it gives NaCl, sodium with potassium with bromine, potassium bromide, but these two reactions are vigorous reaction. But hot alkali metal react directly with what? With sulfur and phosphorus. This reaction is not vigorous reaction to form sodium sulfide and potassium phosphide. The action of alkali metal oxygenated salts. Oxygenated salts such as carbonate is thermally stable, so it doesn't decompose. But lithium carbonate is an exception because lithium represents a weak alkali metal. So lithium carbonate can decompose in the presence of temperature of 1000 degrees Celsius into lithium oxide and carbon dioxide. Alkali nitrate decompose partially. Instead of being nitrate, it will be nitrite and oxygen gas evolves. Potassium nitrate is used in manufacture of gunpowder because potassium nitrate in the presence of heat decompose to KNO3 plus O2 with explosion. So it is used in gunpowder. Extraction of alkali metals from their ores. Alkali metals by using electric circuit can be extracted from the molten sodium chloride. Molten sodium chloride. So we have anode and cathode. Anode has positive charge, so it attracts chloride ion, which carry negative charge. And cathode has negative charge, so it attracts sodium positive. At anode, there is an oxidation for chloride ion to form chlorine gas and the 2 electrons evolves. At cathode, there is reduction for sodium to form sodium atoms at cathode. Alkali metal compounds such as sodium hydroxide. Sodium hydroxide is a hygroscopic substance. So if it is exposed to air, it absorbs the water vapor from air. So sodium hydroxide is a hygroscopic substance. NaOH plus HCl give us NaCl plus H2O. When sodium hydroxide reacts with HCl, it gives NaCl plus H2O. When sodium hydroxide reacts the most important uses of sodium hydroxide. Sodium hydroxide is used in many industries such as textile, such as paper, and so on. But one of the most important uses of sodium hydroxide that it is used to detect the difference between copper cation and aluminum cation by using sodium hydroxide solution. On adding sodium hydroxide on copper ion, it forms blue precipitate of copper hydroxide, as we can see in this picture. On adding sodium hydroxide on aluminum, it forms white precipitate or white gelatinous precipitate of aluminum hydroxide. This white gelatinous precipitate of aluminum hydroxide will disappear on adding more of sodium hydroxide due to formation of what? Of sodium metaluminate. So copper sulfate on adding CuSO4, on adding NaOH, it gives us Na2SO4, which is aqueous, means dissolved in water, and for copper hydroxide, which is a precipitate. If we take this precipitate, which is copper hydroxide, and heat it, it forms a water vapor and copper oxide black as a black precipitate. Aluminum chloride, AlCl3, plus NaOH forms NaCl, which is aqueous, plus AlOH by 3, which is white gelatinous precipitate. This white gelatinous precipitate disappear if we add more of what? Of NaOH, due to formation of sodium metaluminate. Sodium carbonate, Na2CO3 plus HCl, give us NaCl plus H2O plus carbon dioxide. When sodium carbonate, the most important uses of sodium carbonate, it is used in industry, paper industry, textile industry, manufacturing of glass. It is used in removing hardness of water. Finally, we reached lesson 2 of chapter 4, which is talking about group 5A in P block. Group 5A in P block is made up of nitrogen, phosphorus, arsenic, antimony, and bismuth. All of them have 5 electrons in the outermost energy level. So all of them have the electronic configuration which ends with Ns2Np3. General properties of group 5A, the graduation of metallic and non-metallic property. In this period, we can find 2 nonmetals, which are nitrogen and phosphorus. We can find 2 metalloids, which are arsenic and antimony. We can find 1 metal, which is bismuth. Different numbers of molecules of group 5A. For nitrogen, for example, it's found as diatomic molecule. Phosphorus is found as 4 phosphorus, arsenic, and antimony. They are found in vapor state. If they are found in vapor state, they are found as tetra or 4 tetratomic or 4 atomic molecule. Bismuth, as it is representing metal, if it is found in vapor state, it consists of 2 or diatomic molecules. It has several oxidation number, ranges between -3 to +5, because it has ability to share by 3 electrons or gain 3 electrons, and to share or lose 5 electrons. So it has several oxidation number, and also it has several allotropic forms. As you can see, the phosphorus, but we have 2 shapes of phosphorus or 2 colors of phosphorus, white phosphorus and red phosphorus. This is related to what? The arrangement of atoms in their stereo structure. So allotropy, the presence of elements in more than one form which have different physical properties, but they are similar in chemical properties. Oxides of group 5A, as we said, it has a different oxidation number, so we have different oxides. In addition to the type of oxide is different, because we have metals, we have non-metals, we have metalloids, so we can find acidic oxide, which are nitrogen oxides and phosphorus oxides and arsenic oxides. They are acidic oxides. Amphoteric oxide, antimony oxide, and basic oxide for bismuth, because it is representing metal. Hydrides of group 5A, ammonia, NH3, and phosphine, PH3, and arsine, ASH3. These are the hydrides of this group. These hydrides have free lone pair of electron, so they are able to form coordinate bond with any other hydrogen ion. So they dissolve in water, forming NH4OH with a coordinate bond and form basic solution. But due to the difference in electronegativity or the highest polarity of ammonia rather than phosphine, so ammonia is more basic rather than phosphine. The most famous elements in group 5A is nitrogen. How to prepare nitrogen in lab? We have two methods to prepare nitrogen. The first one from the atmospheric air, as we can see here. From the atmospheric air, we have a jar filled with air. Air is a mixture of what? Of carbon dioxide, of water vapor, and of nitrogen. The first one is to pass air on caustic potash, then to concentrated sulfuric acid, then by heating to remove oxygen. So finally, nitrogen is collected. So caustic potash react with what? With carbon dioxide in air. Conc sulfuric acid react with water vapor, which is found in air. And finally, the red hot copper react with oxygen or remove oxygen from the mixture of air, and nitrogen is collected by downward displacement of mercury. Another way in the chemistry lab by using ammonium chloride solution, NH4Cl, and sodium nitrite, NaNO2, to get NH4NO2 plus NaCl. NH4NO2 is not stable, so it decomposes and producing nitrogen gas. The chemical properties of nitrogen. Nitrogen react with hydrogen, forming ammonia with electric spark. React with oxygen with electric arc to form nitric oxide. Nitric oxide react with oxygen to form nitrogen dioxide. With metals, nitrogen react with magnesium with heat, not electric spark, not electric arc. As you can see, electric spark has a temperature of 550, and it is needed to break the bond in nitrogen, triple covalent bond, and the bond in hydrogen. Electric arc, we need more heat to break the triple bond between two nitrogen atoms and the double bond in oxygen between oxygen atoms. With metals, because metals are active, so we need only heat to break the bond, the triple covalent bond in nitrogen. So they react with metals, react with nitrogen, forming magnesium nitride, which dissolves in water, and forming ammonia, which is used as a fertilizer. Calcium carbide. Calcium carbide react with nitrogen in presence of electric arc to give calcium cyanamide and carbon, which calcium cyanamide also used in preparing fertilizers, because when it dissolves in water, forming NH3. The most famous compound in of nitrogen is ammonia gas. Ammonia gas is prepared by reaction between ammonium chloride and slaked lime to produce ammonia gas after passing on calcium oxide to absorb any water vapor. N2, the preparation of ammonia gas in industry. N2 plus H2 give us NH3 in presence of iron and molybdenum at atmospheric pressure 200 and temperature 500 degrees Celsius. Ammonia burns under certain conditions according to this equation. What is the similarity between reactant gases and product gases? We have gases in reactants, which are ammonia gas and oxygen gas. we have gases in products, which are nitrogen gas and water vapor. How they are similar? All of them are heavier than air. All of them are sparingly soluble in water. All of them are colorless. All of them are odorless. For sure, all of them are colorless, because oxygen itself is not heavier than air. So we can say that all of them are heavier than air. All of them is sparingly soluble in water, but ammonia is solved in water easily and forming basic solution. All of them colorless, yes. All of them are odorless. Ammonia has a strong odor. Detection of ammonia gas. How to detect ammonia gas? We detect ammonia gas by using hydrochloric acid, forming white fumes of ammonium chloride. We have two types of nitrogenous fertilizers. We have inorganic nitrogenous fertilizers, such as ammonium nitrate, ammonium sulfate fertilizers, and nitrogenous phosphorus fertilizers. How to prepare ammonium nitrate fertilizers? By reaction between nitric acid and ammonia gas. Nitric acid and ammonia gas give us NH4NO3, which is used as a fertilizer, or by reacting ammonia with sulfuric acid to form ammonium sulfate fertilizer. But ammonium sulfate fertilizer make or cause acidity of the soil. Nitrogenous phosphorus fertilizer, coming from the reaction between ammonia and phosphoric or orthophosphoric acid to form ammonium phosphate. Thanks for all of you. Thanks for watching. Wish you all the best. Assalamu alaikum wa rahmatullahi wa barakatuh.